Hi guys, welcome to the Tech Granth. Today I'm starting the tutorial on the data structures and I'll be starting with arrays. Do like and share the video, subscribe to the channel to get further update. So what are data structures? Basically data structures are the way or the mechanism that has been provided by the various programming language to store data in your computer. So they are basically of two types. We have linear kind of data structure and we have non-linear kind of data structure. Linear kind of data structure are the data structure like arrays, linked list, where you access the data sequentially. And non-linear kind of data structure are the data structure where the access is in a non-linear way, like you have graphs and tree where you have one node connected to various other node. In case of tree or trie that we have, so those are non-linear data structure. We'll go into that in my upcoming videos, so do keep a tab on the channel. We'll see. And when we talk about data structure, generally we talk about the term called ADT, which is the abstract data type. Abstract data type is a process of problem solving where we combine a data structure with its operation, and it gives us a powerful way of programming in any language. So that is about ADT. And ADT, we have like declaration of data and we have declaration of operations. So if I have some set of data for my array or for my linked list, so I can define various operations like insertion, deletion, and all those things, and basically retrieval and all. So that is about ADT. We'll move on with arrays in this video. So what is an array basically? So if you see this diagram over here, this is an array, as simple as that, where we have a linear kind of structure and we store data in this structure based on the indices. Like for each index we store some data in that particular index. So when we talk about array, so array is a data structure or a data type where we store a sequence of element and all those elements belong to a similar type. It cannot be of mixed type. So if I have an integer array here, so all the element of this array should be an integer, and each value, all these integer value will be stored at a particular index, and these are called the index number of the array, and these points to a particular location in memory. So if you see the top numbers, those 200, 204, each of these number denotes the location of the memory location. Basically these are the contiguous memory location in our RAM. So uh, one question that you can see here is that since this is an integer array, each of these blocks, basically each indices, takes 4 byte, because int has a size of 4 byte. So that is why the memory locations are like 200, 204, and so on. Then when we talk about array, the thing that comes to our mind is that whenever we create an array, it allocates one memory block to hold the entire element. Basically it will be one contiguous block that will be created in our RAM where the data will be stored. It is not it cannot be a non-continuous thing. So if you don't have enough memory to store an array while creation time itself, the object creation will fail with some memory error. Next thing that is about array is it is of constant size. So whenever you create an array, you have to define the size of the array. Basically you have to tell what number of elements is going to be in that particular array, and it cannot exceed. It can be less, but it cannot exceed. And in case where you have number of element which is less than the size of the array, the rest of the spaces will be filled with the default value. Like for an int array, if you declared a size of 11 or 12 here, and you have only 5 6 elements, then the remaining will have the value 0. So that is how array will work. And it is pretty simple and easy to work with arrays. And the next key point is that the access of each element is very fast, because the access happens it happens in a constant time. When I say constant time, it means that the time it will take to fetch any element from the array is always same. It does not depend upon the size of the array, and that is why the access is very fast. Now, how the access time is constant? The access time is constant because when we when we retrieve any data from array, we give the index number of the array. So we say int of 1 or int of 0 to get the data. So suppose I want the data 89, so I will say from this array give me the value at position 3. So this position 3 will be mapped to the memory location 212. So the compiler knows to which memory location I have to go and pick up the value for getting the number 89. So that is why the access is very fast. Now, when we talk about the memory allocation for this array, how much memory, if I create an int array, how much memory that array will take in actual. So here is a split of that. So each array, when it is defined, it will have a header that will take a memory of 8 bytes. And for storing the size of the array, when I say here like int of 10, so I have to store this 10 also, so it will take 4 bytes. So this declaration basically it will take 8 plus 4, which is 12 byte of memory. Then the second part will be whatever element you are creating and the type of the element. So again, if I take this example, so this is an array of integer and it has 12 elements here. So the size of this array that these elements will take will be 12 into 4. So that is where the another chunk of space will go. So here I have given an example. If you have an int array of size 10, so the space taken by that array will be 10 into 4, which is 40 bytes. And there will be an additional padding that will happen when you sum up all these number, the header, the storing size, and the size of the element. If the number that comes up, like in this case the number sums up to 40 plus 12, which is 52. So 52 is not a multiple of 8. So if the sum of the bytes or the memory that we have got till now is not a multiple of 8, in that particular case an additional padding will be given to make it a multiple of 8. So here we will have a padding of 4, so that it becomes 56. So the space occupied by an integer array of size 10 will be something like this. It will be 8, which is for header, plus 4 for the storing size of the array, then 10 into 4, which is the actual size that will be occupied by each element, and plus 4, which will be for padding. So it will be 56 byte. And if it is a 2D array kind of thing, so in that case it will be, you have to calculate the size of each array, and then it for each sub array that same size will be replicated. Next important thing that we need to talk about when we talk about array is the search algorithm. So when you retrieve data, you get it from in a constant time, but if you have to search, how you will do the search on an array? So we have two very basic kind of search mechanism, and they are most common. In general, you are going to use binary search because that is very fast, but you have a sequential search or a linear search. So as shown in this particular picture, if you have to find j in this array, how you will find? If you have to do a linear search, so you will look into the first memory location, it is not equal to a, then you will jump to the second location, this is also not equal to j, then again you jump. So sequentially basically you are jumping one position after the other till you reach j. So once you reach j, so that time you will return the position of j in this array. Now if you had to find the position of m, which is the last element here in this array, you had to traverse the whole array. So it means that the sequential search will run in a linear time. So as the input size increases, so will the time of your execution. So it will be executed in order of n. Now that is where the benefit comes when you use binary search. So let us take an example of binary search here. In this array, if you have to find 3, so I have to find the position of 3 using, if I'll use linear search, so I will check for 1, then I will check for 2, and then I will check for 3, so I'll return 3. Or if I have to check, suppose I have to find 9, so in that particular case what I will do, I will start from 1, so I will go to 1, then 2, 3, 4, and so on till I reach 9. Now the benefit with binary search is we will reduce the time complexity from O of n to O of log n. How we will do that is, rather than going to each element, we will go into the middle element. So in this array we will go to the midpoint of the array, and here we will check, suppose I have to find 9 in this array, so I will go to 5 and I will check whether 5 is less than my value or greater than my value which I have to search. So 5 is smaller than my value that I have to search. So next, rather than searching in this whole array, I will search from 5 to 9 in this range. So now again the midpoint will be 7. So again I will see that 7 is less than 9, so next time the midpoint will be 8, and so on. So if you see, the array got reduced from this length to this length, from 5 to 9, then from 7 to 9, and then 8 to 9, and finally at 9 we got the solution. So it is clearly the size of the array was going like 1 by 2, then 1 by 4, and so on, which is a logarithmic time complexity. One restriction that we have with binary search is that the element in your array, it should be sorted. So if your element is not sorted, then binary search will not work. So you have to keep that in mind. Every time you apply binary search, you have to sort your array first. But for a bigger data set, binary search is definitely the choice to go, and most of the time when you are solving a problem in or any competitive programming challenge that you are taking, so there you will find that you have to go with binary search. Okay, so next we have the sorting algorithm for the array. So these are the 4 very common ones that are present. So we have bubble sort, quick sort, insertion sort, and merge sort. So bubble sort, as you can see from the example, each has like very descriptive example. So bubble sort, if you see, what it is doing is, in the first iteration it will try to put the biggest element of the array towards the last. So it will what bubble sort will do is, it will move the largest element to its correct position, which is towards the end. So in first iteration it will move 8, which is the largest element, and it will put it in the last block. In the next iteration it will move 7 to its correct position here, and so on. And just the opposite of this is insertion sort, where we what we do in insertion sort is, we will put the smallest element in first position. So we'll sort in the reverse order. We'll start from here, from the 0th position, and we will pick the smallest element and we'll move it to first location. If you see, 5 has been moved here, then when we reach 3, 3 will be moved before 5, 1 will be moved before 3, and so on. So that way we are pushing the smallest element towards left. In quick sort, what we do is, in quick sort we will create a partition and we will sort about that partition. So what we will do is, generally the last element is considered as partition. So we will sort all the elements before and all the elements after the partition first. So everything after, when we start sorting, so everything after 4 should be greater than 4 and everything before 4 should be less than 4. So that is how the sorting mechanism for quick sort works. Now these three are a little slow because they all run in order of n square. So again, the best way, the best algorithm that happens is that is pretty common and easy to implement. It is merge sort. This happens in a time complexity of order of n log n basically. So how it works is you break the element first. So if you see all these elements, these are broken down into smaller chunks and each of these chunks will be sorted. So if you see these, so each of these are broken into smaller element for sorting purpose, and once it is sorted then each elements will be merged. So if you see these 5 and 6, it got sorted and merged in correct order. Then 1 and 3, it got sorted in correct order. Then 7 and 8, it got sorted in correct order, and then 2 and 4 will be sorted in correct order. Now the merge process will start. So we will merge these two. So it will be merged in this fashion, 1 3 5 and 6. Same thing goes for the right hand side. It will be merged in a similar fashion and it will be sorted. So it will be 2 4 7 8, and finally these two elements, these two smaller arrays, it will be merged together and it will give me the correct answer. So this is how the merge sort algorithm works. Uh, there are multiple other sorting algorithm which are present. You can go through each of them. There are a lot of data available on those algorithm also, but these are the most common ones. Disadvantages of array. When we talk about disadvantages, the biggest disadvantage of the array is it is a fixed size. So whenever we have to work with array, we should precisely know what is the volume of the data that we are going to get, or what is the size of the data, because because we have to define the size of the array at the time of its declaration itself. Otherwise it will yeah, that is how, that is the nuance of the array. So with fixed size comes the memory allocation that happens up front. So the memory allocation for array, it will happen when you declare the array itself. So if you don't, if you're expecting a big size that will come into the array and you want to declare a larger size, so that much memory should be present. Whether you use it or not, that is a different case, but that size of memory should be present in your JVM or whatever compiler you are using. Otherwise it will throw error. And one other issue is insertion issue. So insertion issue is it's not an issue basically, but it takes a longer time. So if you have already defined an array and there are set of numbers that has been inserted in an array, and you want to add some number in the beginning, so you, if you want to retain everything, so you have to basically shift each of the elements towards right, one pace right. So if it's a big array, then that can be little cumbersome. So we'll cover one more thing, and that is how we can use some trick to solve the problem with array. So array can be used to implement something called a bucketing kind of logic, and it is very helpful when you do competitive programming, or you may not use it directly, but as an intermediate step of a lot of questions that you are going to solve, you can use this logic, and it will be very helpful, especially when you do some counting or duplication removal or that kind of scenario. So I'll give you one example here which you can extrapolate to some other questions also that you encounter. So here we need to count the number of elements that is present in the array. So basically I need to give count of 1, which is 2 here, 2 ones are present. Then 2 is only once, 3 is 4 times, and 4 5 6, they are occurring only once in the array. So I need to give the count of each element. So what I can do is I can simply define an array of size 256, or you can choose any number here which fits this input size, or if you don't know the input size, take 256, because that will cover all the ASCII characters. So you define something like this, and then you say for this defined array and whatever input array that has been given, so input array of position 1, you increment it by 1. So what this statement will do is, it will, if I is equals to 0, which is 1, so it will go to array, this defined array, and it will go to position 1, so input array of I0, which is 1, so it will go to 1 and it will increment this value to 1 from 0. Initially when you defined this array, everything was 0 because by default int array will have value 0. So when I go to the second position, which is 2, so here it will go to array of position 2 and it will increment it by 1. Then again it will encounter 1 for position 3, so it will go again to 1 and it will increment the value by 1. So initially we incremented it 1 for position 0, so it will become 2, and so on. It can go on and it will store these numbers, and you can basically loop through this and find the counters. So this is a very healthy trick, or the bucketing trick that you can use in solving the problem for arrays. So that is it for now with respect to array. I'll come up with other data structure in my upcoming videos. I will try to cover as all the data structure, all the complex one also in the upcoming videos. So keep tap on the channel, subscribe to it. We'll see you in the next video. Bye.